Well, hello and welcome to the second sustainability webinar of 2024, a series sponsored by Honeywell Aerospace Technologies. My name is Murdo Morrison and I'm the head of strategic content at FlightGlobal. And our subject today is advanced air mobility and that emerging sector's potential to not only disrupt the way that we travel, but play a significant role in reducing the industry's carbon footprint. Now, AAM is a broad sector which encapsulates everything from eVTOL air taxis, flying cars, and occasionally cargo delivery drones, to more conventional fixed-wing airliners, and even light-on-air concepts such as the Airlander 10 hybrid airship. But what all these creations have in common is that they are different to what's around today, and they're potentially disruptive in that they are harnessing the power of electricity and occasionally hydrogen to offer enhanced mobility options at less cost to the planet. But to do that, they have to go into service and have a long-term profitable business model. And though we seem tantalizingly close, almost all of these programs are at a point where they've either just embarked on test flights or are promising to do so in the next year or two. And none, with the exception of EHang in China, have received any kind of certification. But the regulatory hurdle is not their only challenge. There are still technical mountains to climb, questions over where pilots will come from, uncertainties about ground infrastructure, including the thorny question of charging facilities. Will there be market acceptance from both customers and from a finance sector which is repeatedly asked to risk investment in an industry that is still unproven and still far from generating revenues? And perhaps the biggest question of all, is there room for, at the last count, perhaps 30 or more players who are at an advanced stage of bringing a concept to market? And if not, who among the many will survive and thrive? Now, to debate some of these issues and more, I'm joined by an eminent industry panel, including faces who may be familiar to those who've been following this sector over recent exciting years. But before I introduce them, just a few quick notes on the webinar itself. If you're joining us live, there's an opportunity to ask questions via the Zoom Q&A icon at the bottom of your screen. So please use that rather than the chat icon. And we'll try to get to as many questions as we can over the next 55 minutes or so. So on to our panel. Sapan Shah is the Director of Product Management at Honeywell Aerospace, responsible for leading the development of products and services in the advanced air mobility sector. He has more than 17 years' experience in aerospace product development in both hardware and software, and has negotiated partnerships and licensing agreements with suppliers and vendors. Michael Savenka joined eVTOL aircraft developer Vertical Aerospace in 2019 and is the Bristol-based startup's Chief Commercial and Technology Officer. Prior to Vertical, he worked at Rolls-Royce's civil and military businesses for 20 years, including most recently leading future technologies for the group CTO. Now, we were to have a John Botti, CEO, CTO, and co-founder of Volt Aero, developer of the Casio series of hybrid electric fixed-wing aircraft. Unfortunately, he's had to pull out, but we're delighted to welcome as his replacement, Luciano Belviso, who is Volt Aero's new COO and head of the design organization. He founded Italian training aircraft manufacturer Blackshape, and alongside his role at Volt Aero, is an investor in deep tech startups. David McBride is Supernal's CTO, leading the Hyundai-owned company's eVTOL development with a goal of service entry by 2028. He was previously director of NASA's Armstrong Flight Research Center, overseeing projects such as the Boeing 747 SP, the Stratospheric Observatory for Infrared Astronomy, or SOFIA, as well as the X-59 quiet supersonic aircraft and the all-electric X-57 Maxwell. Now, I'm going to ask our three of our four panelists to start by telling us a little bit about their company and their business model and their flagship project and what the very latest is in terms of its certification. But before that, I'm going to start with Sapan. Sapan, it could be said that Honeywell is spreading its bets when it comes to AAM. You're backing many of the horses in the race, and you even have equity stakes in some of them. But we should just make it clear that despite what's behind you on that screen, Sapan, Honeywell has no aspirations to become an AAM manufacturer in its own right. So everyone else can sleep soundly on that. But you know, what is Honeywell's offer in this sector?
Thank you. First of all, thank you for the question and inviting me to the panel. So Honeywell Aerospace Technologies, we're about 24,000 employees strong. We're on 400 different platforms, right? So even before advanced air mobility, we've already on several different platforms. And we are very deeply committed to the field of advanced air mobility. Our focus area within aerospace itself is all the way from autonomy to avionics, from connectivity to cooling, turbo machinery, electrification. And in the advanced air mobility sector, just like other market segments, we're not building the airframe, but we are providing everything from nose to tail. Specifically, we are providing sensors and navigation system that forms the eyes and ears of the aircraft. We are providing avionics and flight computer through the Honeywell Anthem system, which forms sort of like the brain of the aircraft. We are providing thermal management to provide cooling for the cabin if you're operating in Middle East, in Americas, in other parts of the world where it's going to get really hot. And also the same cooling can also be used for cool other systems on the aircraft. We also providing the motors and actuators that essentially form the muscles for the aircraft. And then finally, we have connectivity solutions, satellite connectivity, as well as ground control station for remotely piloted operations. And these are not technologies, these are actual programs that will be in the market as within entry into service in next 12 to 24 months. And beyond all of these products, Honeywell is also heavily invested in research and development for this segment, thinking about how do we bring in automation, advanced automation, autonomy, things like pilot monitoring of the state of the pilot in single operation or reduced crew operation, and also things like hydrogen fuel cells. And so those are a lot of different new technologies that the team's working on. And finally, one more thing I would like to add here is another thing that I am really proud of is the work that Honeywell is doing with our customers and even the other OEMs, they may not be our customers, and just the ecosystem partners is bringing everybody together, leveraging Honeywell's relationship with the regulators, with the legislators to help raise the issues that the industry is facing. And to get the support required from whether it's Congress, FAA, or regulators to make this a reality. And one small example of this is the summit that Honeywell hosts in DC, where we invite all the OEMs, the regulators, the members of Congress to bring up the issues that require immediate support from all the stakeholders. So through all of these efforts, Honeywell is not only contributing to the technology, but also trying to foster the regulatory and the infrastructure environment necessary to be successful in AAM.
Great, thank you, Sapan. Michael, I'm going to come to you next. Tell us a little bit about vertical aerospace and where the VX4 program is at the moment. Now, you had that mishap last year, and a month ago, I think you talked about a flight test campaign resuming in the coming weeks.
Yeah, well, maybe if I start with the company, thanks for inviting me. So Vertical is really the UK's only credible eVTOL company, one of the leaders in this space globally. We were actually founded about 6 years ago, so we're one of the older players by successful British entrepreneur Stephen Fitzpatrick. Stephen's successfully already founded billion-pound companies or dollar companies, and got into Vertical actually through an interesting route. He was a big fan of Formula One. At one point owned a Formula One team. In fact, Vertical was spun out of Formula One as a mechanism to try and leverage some of the F1 tech. But very quickly realized that actually this is a sort of full-blown aerospace endeavor. So we're now about 350 employees. We're based in Bristol. Bristol, for those of you who don't know, about 100 miles west of London. That is the epicenter of the UK's aviation ecosystem. So surrounded by something like 270 aerospace companies, all the big names amongst that. Brilliant for talent, brilliant for some of the testing facilities, research, supply chain, etc. We've had, I think, from the outset, a business strategy that definitely is distinct from quite a few of our competitors, in that we, I think, are very much focused on being an OEM. So we've never intended to operate the aircraft. But having spent now 2.5 decades in aviation, what aviation has traditionally become very good at is developing incremental improvements on an existing platform. And so if you think about the sort of big OEMs, the Boeings, the Airbuses, the helicopter manufacturers, they make steady improvements every year. And they're phenomenally good at doing that with lots of kind of barriers to entry. But really, electrification opens up a completely new way of designing the aircraft. You know, we're doing an aircraft that doesn't look like a helicopter or a fixed wing aircraft. And there isn't really a playbook for how you do that. And so I mean, I've been working in eVTOLs 9 years ago, and even in my Rolls-Royce days when we were looking to be a sort of propulsion provider, it was very clear to me that actually this was a space where startups could really differentiate through the pace and agility, the speed of learning, and the barriers to entry are different. So that's at a platform level. So Vertical looks after the whole aircraft. We have some specific expertise we can go into in terms of propellers and battery systems in particular, which are very novel and deep technologies in these kind of applications. But wherever possible, our general aim has been to partner with strategic suppliers to leverage everything that Sapan talked about. And in fact, Honeywell, 5 years ago nearly, was the first strategic supplier that we signed up on contract. I think we were the first eVTOL company that Honeywell signed. And really the model was, how do we combine the pace, agility, single product focus of a startup with the deep incumbent R&T technology pipelines, the certification know-how and pedigree, the industrial capabilities and the aftermarket support that companies like Honeywell, Leonardo, GKN, our other strategic suppliers bring. And then on the customer side, we've been, I think, humbled and kind of fortunate in building really what I think is the world's best customer order book in terms of quality. So we've not gone after pure numbers. We've sold about 1,500 aircraft, roughly split 1/3 North and South America, 1/3 Europe and the UK, and 1/3 in Asia. But a range of operators from sort of big names like Japan Airlines, American Airlines, Virgin Atlantic, sort of classic airline companies. Avalon is the second biggest leasing company. So bear in mind, 40–50% of aircraft today are bought by leasing companies. We've got tourism operators. We've got helicopter operators like Bristow. So a whole sort of range of different customers, and I'm sure we can have lots more discussions around that customer base and the use cases and the economics as you teed up. Just in terms of where the company is, I mean, I touched on the fact there isn't a playbook for how you design these things, and it's very much learning by doing. We've flown, in fact, 3 prototypes, including the one behind me. The one behind me was the first full-scale winged vehicle that we did, and really the objective of that was just to understand how these things get put together, learn from doing, validate many of those engineering models, and enable us to do that at full scale, which is much, much more difficult than doing subscale. So we're not extrapolating those models a long way. And you can imagine with the weight of batteries, it's quite a fine line to actually get a vehicle that can close and do a useful commercial payload. We did have a mishap. Actually, it was a very fortunate one. It was right at the end of the testing. It was a very early standard of prototype. We only had about 10% of our strategic suppliers on board. We captured, in fact, all of the learning we'd intended to and more. And we were doing some additional sort of extreme envelope failure cases to test out. We've now jumped to a far more sophisticated vehicle. So the aircraft we are in the final throes of build will be flying in the coming weeks and months. from the outset has been designed as a piloted vehicle. It has the majority of our strategic suppliers involved heavily. So we've gone really from a sort of rapid prototyping world to something that is really much closer to a certain aircraft. In the UK, where we will fly piloted. So I think potentially we will be the first listed company and one of very few to do a full-scale piloted transition targeting later this year. And actually to do that in the UK is almost like a mini cert program, because we don't tend to have very remote areas in the UK. The minute you put a pilot on board, we have to go through an extensive permit to fly process with the authorities, really demonstrating the acceptable safety standards, both for the pilot, but also third-party risks. So if you like, this is a brilliant proving ground for cert. And then beyond that, we get into doing the actual cert program. We're targeting end 2026 for the final or the entry into service variant, which will be 1 pilot, 4 passengers. And I'll stop there to allow others to talk.
Thanks, Michael. We'll get on to a lot of these issues later on, including that whole question around piloted and autonomy and potential autonomy and so on. So we'll I'm sure come on to that later. David, I think it would be correct to say that Supernal's perhaps a little bit further back than some of the others on the racetrack. You're looking at a market entry in 2028, I believe. So where are you, and what are the next steps?
Yeah, thank you, Murdo. Where we are right now is we're putting together or fabricating right now our full-scale technology demonstrator. We'll fly that vehicle by the end of the year, and we've got a full cadence of design efforts going on with our production vehicle, the SA2, which we unveiled this year in CES in Las Vegas in January. We'll show that at the model in Farnborough again and talk there and visit with a lot of our suppliers and vendors. That'll be a big exposure. We're wrapping up the design of that vehicle. Obviously, you mentioned it and Michael mentioned it. You know, the goal is to have a safe entry into the market. This industry needs to have safe players, and to get the traveling public comfortable with eVTOL and AAM is a demonstrated safety capability and a safe product that can link the entire transportation ecosystem, from long haul transport using eVTOLs for that connection to the urban environment, and also connecting the ecosystem to the last few miles to their final destination with automobile links as well. So we're looking at the entire ecosystem in this AAM market. Where we are is our facility, our design center is located in Irvine, California. We've got about 650 or so employees spread across our facilities here in Irvine, plus a design center in Silicon Valley in Fremont, California. Our goal is to, like you said, open up the AAM market to the world, to change transportation as we see it. Big challenges in working with vendors. Even our tier 1 vendors aren't necessarily used to working with this nimble small business or small company setup, and the growth potential and the volumes we're talking about is way out of scope for even our tier 1 vendors. Michael mentioned Formula One. You know, we're connected to Hyundai, which is obviously a large automotive conglomerate, and they see us as part of their Formula One team, if you will, in advancing technology that'll go into the automobile sector as well, with batteries, battery management system, motors, and so forth. So we're leaning on proven technology where it's practical, following the market with things like batteries, because the eVTOL market definitely will not be big enough to drive battery chemistry and battery cells, but we'll take advantage of all the advantages and improvements in battery technology as we go, and then innovating with a power plant, with the whole powertrain system. Like Michael said, useful payload is what we're designing toward, making this a product, and all of us are chasing after that same useful payload. So a lot of our competitors are ahead of us flying already, but we need to get to where we can turn this into a commercial product. And it's been mentioned already, it's got to be a commercial, profitable business in the end product, not just a demonstration vehicle, but something that can turn into a product. I believe there's room in the market for many players. You mentioned 30 players, maybe not 30, but there's certainly room for a strong handful of players in this market, just like the automobile industry.
Okay, that's really interesting. Okay, thank you. And finally, Luciano, the Casio is different from the other two aircraft whose companies are represented here today, in that it's a fixed wing aircraft rather than an eVTOL. And it's not even a pure electric design, in that it incorporates a battery and a conventional piston engine. So tell us a little bit about why you went down that route and what news we can expect from Bolt Aero this year.
Yeah, absolutely. Well, thanks a lot for the invitation first. So, well, as you know, Bolt Aero is a French-based startup founded by, among others, the former Airbus CTO, Jean-Baptiste. And actually, the nice thing is that the entirely leverage, I would say, around 15 years of experience in the field of electric aviation, I would say sustainable aviation. I can mention, among others, programs like, the CRI, EFAN, and so on. The main project at the moment is the Casio 330, is the first one of a family of 3 different aircraft. The 330 is going to be up to 6 seats. And as mentioned, it's a fixed wing, is a 3-surface configuration with hybrid powertrain. Well, the reason why we decided to stay on the fixed wing configuration is primarily because of the viability of the business. So in the end, and same for the choice of the hybrid propulsion. So I would say when transitioning from, I would say, PowerPoint to the real world, everybody of us faces, challenges that are extremely important. And that's the case actually of our analysis. In the end, say purely electric propulsion means that energy storage is really the issue. And actually, after, I would say, almost a decade where everybody was expecting a steep increase in terms of energy storage capabilities, we are, I would say, obviously with an increase, but a completely different slope than what could, be anticipated. So actually, when we started a few years ago to consider this hybrid configuration, it's in the sense that just incremental steps towards a clear and form production, which needs to be viable also in terms of the business model. So the 3 things that we aim to achieve with this configuration is, first of all, reducing the total cost of ownership of the aircraft. So again, it's said is a more conventional configuration. Still, it's quite, let's say, particular because, as I said, it's very well optimized for efficiency, for the operability, especially from shore fields. But yeah, we wanted to enhance the viability in terms of total cost of ownership. As a consequence, just reducing the amount of fuel, also having an impact in terms of carbon footprint. But yeah, as said, we also wanted to make sure that we can meet the customer and the market expectation. So our, let's say, within our scope, really there's the priority to be capable to deliver some results and I would say reducing the risk. As you can imagine, we are working very closely with regulators, both on the European and the US side. And I mean, even for the hybrid propulsion, there's a number of unknowns, simply because it's something that never nobody certified before. And the recipe that we identify is really to have a lot of growth potential. So the point is that at the moment we plan to have some of the mission profiles that might be operating on purely electric energy. But of course, just to make sure that our market is satisfied with the use of the aircraft, we have to consider also, let's say, more conventional form of bringing energy on board. Just a quick note on, let's say, where we are. As I said, our approach might appear a bit conservative. In the end, it's not, because as said before, we just rely and we leverage the experience made by bigger companies, just promoting a disruption, but with different consecutive steps. So it's been 4 years that we've been flying on our development platform. It's based on a completely modified baseline aircraft, which flew already 4 years ago our hybrid powertrain. So now we have a massive experience in terms of the powertrain, which is the core, of course, of the innovation in our project. And we are working for the last, was it 6 months, on the first representative test article, which we plan to put in flight the order of magnitude this month.
Okay. Thank you. Thank you very much for that. There's so much to cover in this webinar. I almost don't know where to start, but I'm going to start with the whole sustainability question. This is a sustainability webinar. And this sort of gets us into perhaps some of the use cases. So we are talking about these disruptive aircraft that are going to be their cell is their part of their cell is their sustainability. But do you expect them to will these sort of replace existing modes of transport? Will they supplement existing modes of transport, or will they completely open up new routes and new markets in transportation, such as urban transportation, for example? What are your thoughts on that? Let's go back and perhaps start with Sapan to get maybe a more industry-wide point of view on that.
Yeah, thanks, Murdo. So I think the way I kind of think about the use cases, they're quite varied. And I want to kind of bring in a little different angle to this question, is sort of like, what are the passengers or the community accepting these vehicles to be used for? So there was a survey done by EASA about 4 to 5 years ago. And then recently there was another survey done by the Transportation Committee in Canada. And the results from both of them were nearly identical, right? Like 5 years later around the globe. Essentially, that said that the community accepts these vehicles first to be used for emergency services, whether it's fire, medical, law enforcement. And then comes sort of like the big expectation, the use cases around air taxi, cargo delivery. Now, I think what this kind of highlights is some of the work that the industry needs to do in sort of like getting the community to understand and accept all of these use cases. So I think the use cases are quite varied. It's almost all of them, including defense applications here. But I think there's a lot of work that needs to happen together with the industry in sort of like educating the community, understanding their pushbacks around supporting these for emergency services, but maybe not as excited about other use cases, and trying to understand what the pushback is and then helping educate and get them on board to actually adopt this as a use case for even transportation.
Okay, that's really interesting. Michael, VX4, is this a sort of lower cost helicopter or an expensive Uber? What's the sort of use case for your aircraft?
It's interesting you mention Uber. For me, Uber did some brilliant things for this market in setting up Uber Elevate. It brought in an awareness of the opportunity of eVTOLs. It brought in funding. It brought in talent. Actually, in the early days, I think they really did a really good job in defining a starting perspective for what the sort of a reasonable vehicle specification might look like. I think the bit they didn't help the market on was actually overhyping this is an on-demand utility, a flying car, a flying taxi, what have you. We might get there, but that's not how this market starts. You think about any kind of novel product, whether it's a phone or whatever, mobile phone, these always start as more of a premium service, and then they have sort of really important purposeful use cases like Sapan's just talked about. And I mean, we've got, I think, the huge advantage of this global customer base that we built up over time, and we've jointly done a huge amount of network modeling, whether it's looking at mobile phone data, economic modeling, to really understand what the kind of missions are that are going to be flown. And if you look in the round, the main missions fall predominantly into 3 categories, and I'm talking in this case passenger carrying. So we took a very conscious decision to focus on passenger carrying. There are clearly, as has already been highlighted, cargo and military opportunities, but we think the biggest market opportunity ultimately will be passenger carrying, because fundamentally we're saving time, and people are generally more time sensitive. And essentially the three use cases are connecting major airports to the surrounding catchment area. So that's not necessarily going right into the middle of the city where there might already be good kind of ground infrastructure, but that surrounding catchment area. There are plenty of early use cases around tourism. So whether it's sightseeing or flying to kind of remote locations, hotels, whatever. And then there are lots of use cases where there are just gaps in the ground transportation infrastructure, and it might be because there are mountains in the way, bodies of water or whatever. On day one, the services are going to be scheduled, and it's essentially going to be flying back and forth. Bear in mind, you can use existing infrastructure like vertiports, runways, and so on, but you need a charging station. And we are going to be supply constrained. So I fully agree with David's comments that there is room for several players. There will be a handful of players, but we're all going to be supply constrained in the early days. And in fact, Vertical's approach very much is certify an aircraft with the best available existing technology. Don't rely on something that is kind of in a lab. Wherever possible, leverage the industrial capabilities that already exist in the supply chain, so you're not investing vast amounts of money in new factories on day one. And then I think a few years after entry in service, there will be a pivot where we start getting into much higher volumes, and it'll go from tens to hundreds to, maybe 1,000-2,000 vehicles a year. It's certainly not going to whiz up to the hundreds of thousands that the sort of classic automotive does. So think much more kind of high-end automotive in terms of volumes. So with that ramp up, I think inevitably you start supply constrained in the most premium high value routes. And then over time, to your point, well, why does this disrupt? We are deliberately certifying to the very highest safety standards being set globally. That is equivalent to a transport category aircraft, so a big airline that you would get on. So that's about 100 times safer than a helicopter with no single point failures. The aircraft is 30 times quieter in hover and 100 times quieter in cruise than a helicopter. So in hover, it's about the sound of a loud conversation. In cruise, it's a domestic fridge. You literally won't hear it. It is, depending on the metric, somewhere around a third to a fifth of the operating cost of a helicopter, and it is zero emissions. So one of the reasons I got into this space is because we're not just putting a battery or a powertrain in an existing aircraft, we can really disrupt how we design the aircraft and offer all of these other features. So of course, that combination of things, if you think about helicopters today, they are largely banned from operating over major urban areas because of safety and noise. This disrupts and opens that. Helicopters are never going to be a mass transport mode because, Bristow, one of our customers, every 1 hour of flying, they're doing 3 to 4 hours of maintenance, and huge cost in operating a helicopter that we just avoid by having an electric powertrain. The missions are actually quite short, so probably 50% of the flights are less than about 30-35 miles. Because you're flying in and out of a vertiport where people want to go, you actually can fly a relatively short distance and beat the traffic and save quite a lot of time. So you can do that with batteries. But I think it's going to be that gradual ramp up from premium down to over time, certainly next decade. This is something that most people will be able to afford, but it won't get there on day one.
Okay, thank you. David, who will Supernal's customers be?
I think Michael covered it well. The initial market will be a premium service, more like almost any new product on the line, whether it's personal computers or smartphones or cell phones, period. You'll grow up from a premium service. Price-wise, you mentioned Uber, ride-hailing services. The initial price point will be maybe a little bit more expensive than an Uber Black, but probably not more. And the luxury for that class, that upper tier traveler, is going to be time saved. Will there be market acceptance? Every time I get on the freeway in Southern California, I realize there will be immediate market acceptance. As Michael described, I don't think there'll be public rejection either, because this will be so quiet in an urban environment. At around 45 dB in cruise, you won't even notice it. The most you'll see, notice it is the shadow flying over you. And so it's not community acceptance. Don't see as a risk if we all stick to our goals of the levels of safety we want to build to and operate at. I think community acceptance will be in 5 years after we enter the market. It'll just be a common mode. to get around. It'll make some big breakthroughs by relieving traffic, and the public will also be happy because it'll take a certain percentage of the traffic capacity of the freeways and highways back into the air, and so they'll be happy that there's a reduction in volume there, and people getting somewhere faster will be happy. There's not really a downside to this. You brought up some issues early in your conversation about capacity for vertiports, and I think we'll grow that capacity will grow. Communities will quickly accept them and identify known routes and known vertiports. Pilot training, that's also another challenge, but we are, and I'm sure all our competitors are, designing a simplified vehicle operations mode where the level of training won't be as critical as flying a fighter jet with and that's more complicated than the typical transport as far as overall systems that somebody has to be aware of and paying attention to. And maintenance, I'm a very happy driver of an electric automobile for the last decade. And if we can make our vehicles as maintenance efficient as my Tesla is over 10 years, the users of the vehicles will be extremely happy too. Yeah, Michael hit it right on the head with helicopters needing so much maintenance for every hour of flight, and my Tesla over a decade has needed almost zero maintenance except for changing the tires. So it'll be, I believe, the maintenance, the serviceability, training, all of those are going to be orders of magnitude lower cost than conventional aircraft or rotorcraft.
Okay, that you bring up some really interesting topics there, which I want to come on to in the next question when I'm going to be talking a bit more about autonomy and safety and so on. But let's just go on to Luciano with that same question about customers. Now you're slightly different in that it's fixed wing aircraft. It's not vertical takeoff and landing. So the use case is going to be very different, I'd imagine, for the Casio aircraft. Can you just maybe talk about what these will be?
Yeah, absolutely. Well, actually, in the end, our two reference value pools are either, let's say, people in need to commute and private customers. I have to say the market is huge, and just to go back to your question, I think it's just a combination of both existing market transitioning towards new form of mobility and also a completely new market, which is going to be, let's say, open thanks to this kind of innovation. Of course, pending social acceptance, depending on the many aspects. But actually, in for what we see from our perspective, the three elements that are really paramount to make sure that the market accept the plane is infrastructure, viability, and sustainability. So infrastructure, in our case, it's quite easy because we want to use existing infrastructure, existing airports, which in the end, let's say, lowered the needs to make something specific to operate. Probably viability is the main thing because it connected, and I think it's really connected to the size of the value pool. So a viable business case, I mean, for the operator means that the business case is scalable, so it can scale up very quickly. And I think, from my perspective, we don't think, we never, let's say, consider in our assumption that the customer will pay for either innovation or sustainability. The customer will seek convenient total cost of ownership, and that's the main thing. Of course, sustainability might play a role, and of course, as you're aware, regulators are also considering to put some efforts, even in terms of financial resources, to promote sustainability. But this is, I mean, far away from compensating the extra cost. And when we go to the sustainability point, which is, of course, just part of the, let's say, ethics of the business, the most important thing is to I mean, not to forget the life cycle of the aircraft, because of course it's quite obvious that that an aircraft, especially, let's say, powered by electric motor, will lower the pollution during the flight. But of course, in terms of life cycle, there are a number of constraints. Even in our case, we have actually, of course, energy storage with a battery. And one of the biggest issue that we are facing at the moment is to really agree with our partners I would say commitment for a life cycle, because at the moment majority of battery suppliers are considering very weak options for second life, which of course in the end has a huge impact. And staying on the sustainability side, there are actually other aspects that are probably very well perceived by the customer base. For instance, noise. I mean, everybody I think is mentioning noise. France, at this regard, is really forward-looking, because is the country in the world with the highest standard in terms of noise, which probably will be a good enabler also to open up, to say, some specific connections in our case.
I mean, we've got about 20 minutes left, so I'm going to ask to try and get through as many questions as possible. I'll ask you to be a little bit quicker in your answers, if that's okay, just so we can get some more covered. So I'm going to move on to we've got some questions from the audience coming in. I want to get through some of these as well. So that whole question of potential autonomy down the line. So are you designing your aircraft to be eventually autonomous? And is that something that you see as being a natural progression for the industry at some point? Who would like to come in on that one? Michael?
Yeah, I'm happy to come in. I mean, I think we start from a fantastic platform. We're working with Honeywell. It's already been touched on, simplified vehicle operations. Inherently, these vehicles are very digital. They'll have full fly-by-wire systems, actually using some of the technology Honeywell's developed for the F-35. And literally, if you came to Bristol, my 9-year-old daughter could fly our simulator and do a nice flight and land it. On day one, we're going to have commercial pilots, not because the aircraft are difficult to fly, but they're going to operate in complex airspace. So you need that commercial expertise to understand how do you navigate through complex airspace, how do you deal with arisings and so on. But I would see clearly cargo and military are going to get there first. Flying over rural areas is going to happen before paying passengers over cities. We're going to have lots and lots of time having to drop in increasing levels of automation to prove to the regulators and the public that actually the pilot does less and less. And I think there's two kind of waypoints on this. One is we'll start with commercial pilots, but over time we will get to the point where the pilot training barrier and maybe ab initio, so brand new pilots who've got a private pilot's license, this becomes the first vehicle they fly on. And then clearly at some point we'll reach the point where the aircraft will be remotely supervised. And actually my view is eVTOL probably will be the first commercial passenger carrying aircraft that become autonomous. We've already seen that in China. There isn't yet a sort of formalized regulatory pathway. There's a lot of good thinking, particularly from EASA, on how to get there. But there's a really compelling commercial value proposition. If you're carrying 4 passengers and you can take the pilot off the aircraft and you can reduce the cost of the pilot, that really drives it. And you don't have some of the legacy union barriers that you might have in bigger aircraft.
Okay. Anyone else want to come in quickly on the autonomy question? David? Yeah,
I think Michael covered it well. Autonomy, we're building our vehicle with autonomy in mind and have an advanced R&D group looking at that. The airspace is actually much easier to automate than automobile traffic, because we'd be dealing with a more cooperative group of other flyers in the air. Obviously, you're going to have some hot air balloons and some untraceable or untracked air traffic, but it's actually a much easier problem to solve than driving in an urban environment where roads are disrupted and there's traffic barriers and children with soccer balls on the roads. So it's easier to, I believe, to automate, and it will be the first true realm for autonomous flight.
Okay, Sapam, would you just like to come in quickly on where Honeywell is with the technology on this?
Yeah, absolutely. I'll just take like 30 seconds to answer that. So I think David and Michael already covered And I fully agree with both of them that things are already simplified and quickly moving towards our autonomy. But when we talk about autonomy, just in aviation, not just AAM, I think we kind of really talk highly automation and autonomy used interchangeably. And not just in advanced air mobility, but even in other vertical segments, we see the aviation and definitely Honeywell moving in more and more towards autonomy. Where we today have 3 pilots in a cockpit going from LA to London, how do we get from 3 to 2, reduce crew operation, going from 2 to 1 single pilot operation? So Honeywell is has several research projects across the world to bring in autonomy, not on just advanced air mobility, but throughout aviation.
Okay. Luciano, I'll come on to you with a different question, if that's all right, because I've got a question from the audience from Caitlin about, and this is around the sort of the challenge of getting engineering talent. Now, I think some of you talked about how many people you're employing. You've obviously got some very, very clever people working for your organizations. How difficult has it been? Michael, you talked about being in Bristol, home to Airbus and GKN and many others. How difficult has it been to get the engineering talent that you need? Luciano, do you want to maybe have a go at that one?
Yeah, absolutely. I mean, we're located in France, where, of course, there's a long standing tradition of aircraft manufacturing. I would say one of the big challenges is not really finding talents. I mean, with a very high degree of knowledge in aerospace, but rather, especially people coming from large aircraft, to really, let's say, have the right mindset, which is to integrate everything at the aircraft level. It's more difficult because in the end, I think the difficulties of general aviation, of a small aircraft, is to have a higher degree of integration of all the system. And that's something which I mean is not always easy to be exposed to in larger companies.
Okay. And the others, have you sort of drawn from aerospace engineers, or have you brought in people with maybe thinking a little bit differently, people from other industries, from automotive, from the sort of the tech industry, David?
Yeah, we've had great luck bringing in people. California is certainly a hub for aerospace innovation, from low-speed flight UAVs through hypersonic and SpaceX and orbital access. So we're able to draw from that pool of experienced engineers, but we're also bringing in people from the automotive industry, from the satellite industry, to help innovate new powertrains, new power plants for our vehicles. So we're bringing in people who haven't worked in aerospace before. And so that's one of our challenges, is to get them up to speed on the challenges of certification. It's easy to design in your mind or on paper a high energy density motor or battery storage system, but to turn that into a certified product that'll get us through EASA or FAA certification is another challenge. But right here in Southern California, we have an incredible pool of people, and it's been relatively easy to attract talent from all over the world to come support us.
Okay, Michael, do you want to go into that quickly?
Just brief. Well, firstly, I think it's a really compelling proposition. We're working on a really purposeful, very cool product. Some really exciting companies, lots of innovation. We have the plus in the UK of having a wealth of aerospace experience.
We've just lost you there, Michael, for a second.
I would say is from aerospace, except for the powertrain. Oh, have you got me back?
Yes, I think we have. Yes, I think we got the gist of that. So
I'll
move on.
Mix of sort of aerospace and automotive, wide range of others. I think part of it is finding people who've got that aerospace expertise, but then can innovate in a different way and have perhaps a different attitude in terms of dealing with ambiguity. And that's one of the things a startup really appeals to many of the kind of talent out there.
Right. Okay. We've just got 10 minutes left. I'm going to try and get through about 3 questions here. So there's been a lot of talk about where the whole AAM revolution will start first. We've seen obviously what's going on in China with EHang. We've seen moves in the Middle East, particularly in the UAE, parts of Southeast Asia, the US, even Europe, with talk of flights at the Olympics in Paris. I'm not sure whether that will happen now, but in terms of geographies, where do you think the early adopters of this industry will be. Sapan, do you want to come in on that first?
Yeah. I think China, I really foresee the commercial cargo operations and the air taxi operations will start operating at a scale that's going to surprise all of us, once within the industry and even outside the industry. Now, I know generally we hear a lot from sort of like Western companies, but I think the scale in China is going to be just grow up really rapidly here very shortly. Beyond that, I definitely see Middle East, Brazil, India are some are going to be the key places where we're going to see some early operations, especially Middle East. And some of that is really around the regulation uncertainty that have been created, especially in the US. So I would say that's really some of the starting point. But I think beyond 3 to 4 years from now, if we think about the LA Olympics, I think by the time we get there, I would anticipate that there is going to be operations all over the world, in Europe, in major metropolitans in area, in US, operating already at a respectable scale, both for air taxi operations as well as cargo operations.
Okay. Luciana, would you want to come in on that?
Well, I mean, I hope so in the end, because we have Paris Olympic Games where air taxi operation were expected, but in the end, this is not going to take place. I would say I agree for sure. New entrants will be the early adopters. The point is that the regulators are, I would say, we cannot avoid to consider both EASA and the US as the leading regulators, and we do so with very soon realize that we have in the end 2 players, Boeing and Airbus, and so it's such a narrow bottleneck certification, which I will be very happy, let's say, to see when things starts to move forward in the Western countries.
Okay, David, you're obviously Supernal is owned by Hyundai. Do you see South Korea being an early adopter in this market, or what other markets do you see as being the first into
Yeah,
this?
absolutely. Based on where we are for the design center and our initial build capacity, and where our primary stakeholder is, Southern California and South Korea are our target entry markets. But I see rapid adoption once these vehicles start operating. The volume of production probably can't keep up with the demands in those 2 markets for several years. So we'll be rapidly building up our manufacturing capability to expand beyond that. But once they're adopted, once they're a proven transportation mode, I think the uptake in utilization around the globe will be incredible. And for the other use case, we've heard cargo mentioned a lot. Even the primary case, I believe, will be air taxi transportation of people during the days, but overnight, a user will be using these to move high-value mail packages, medical supplies, for instance, around urban areas overnight, so they can get 24-hour utilization out of the platform, and then back to passenger transportation with the first early landings at a local airport. So I think I can imagine, and they're so quiet, I can imagine a 24-hour operation from our user base.
That's very interesting. That's something that's not talked about very often. That making that 24-hour operation, if the regulators will allow that, to get that better economy out of the aircraft. Michael, will Europe sort of be last in the queue for adopting eVTOLs?
No, I don't think so. I mean, there's different use cases in different parts of the world. We're actually working with 5 regulators globally. So the UK Civil Aviation Authority, European EASA, FAA in America, JCAB in Japan, which we've not talked about. Actually, if you'd asked me a few years ago, I wouldn't necessarily have said Japan was an early market, actually driven by things like Osaka Expo and a lot of local support. Japan's actually a really good market. And then ANAC in Brazil. Think of Sao Paulo, it's the biggest single engine helicopter market in the world. So I think a wide variety of initial use cases, and we'll build out from there.
Okay, I'm going to ask you to be very quick on the next two questions. We've literally got 5 minutes left, so 30-second answers if possible. I've got a question from Eric on capital needs, and this is one that we said we'd talk about. Without going into too much detail and perhaps talking a bit more generally, there are lots of you out there, all needing a lot of capital at the moment to get your aircraft over the line and into production. Is there enough investment out there? Are there enough backers? Is there going to be enough money out there to make the industry sustainable? Anyone want to come in on that one?
Yeah, I'm happy to come in on it.
Yeah.
I mean, it's a really good question. It is hundreds of millions at least. I think we have a big plus in that focused business model with supply chain partners and customers. So we're not trying to do everything. That means we're spending probably a quarter or less of what the equivalent peers are for pretty comparable progress. We've been lucky having a billionaire entrepreneur to found us. I would say we've gone through the sort of SPAC hype and bubble. There is still money out there for credible players. There is a degree of competition for that capital. I think it's about having a really well-articulated strategy and story, a clear sort of route to generating revenue, and then the upside potential is really big. You know, we've sized the business where we don't have to produce thousands of aircraft to be very profitable very early on. So I think if you can tell the right narrative, you've got the right strategic endorsement and partners, then raising money is certainly possible.
Okay, does one other person want to come in on that, on the capital side of it? Luciano?
Well, yeah, I would say, yeah, of course, it's a key issue for everybody. But what I say is, we like to be very, smooth in the approach. I totally agree. Players must be credible. And I think it also needs to be responsible, because in the end, it's very important that the capital market is educated to aviation. This has been quite recent. I mean, the hype for vertical mobility was a complete novelty over the past few years, and I think we, as an OEM, we have really to be responsible, not miss the opportunity to really educate the expectations of the investors, without, let's say, promising too much, but really, let's say, keeping on track and delivering the promised results.
Okay, time's getting really, really tight. So this is literally got 30 seconds on this last answer. If we're sitting here 5 years from now, or the end of the decade, where will the AAM industry be? Sapan, let's get your glance into your crystal ball for that one.
Yeah, I think we would see lots of flights in LA Olympics. Passengers would have taken flights to go back and forth between downtown and Irvine to see the games. And all of us and our family would have been in one.
Okay. Yeah. Michael, where are we going to be 2028, 2029?
I think a few credible players that will have certified starting the initial operations and demonstrating what an amazing value proposition this offers to customers.
Great. David?
Yes, we'll be kicking off passenger service with our customers. I think it's a bright future from there. Once the world sees what these vehicles can do and how non-disruptive they are to the rest of the community, I think they'll be easily accepted, and we'll see several players kick off in a big way going from 28 into the 30s.
Okay, and Luciano?
Yeah, no, I agree. There will be definitely some key players, credible players. I mean, we'll be there.
Okay, brilliant. Well, good luck to all of you. And that brings us almost to the end of our session. I'm sorry we didn't get round to more of your the audience questions. We had some really great ones coming in. But I'd like to give a huge thanks to our panel today for giving so generously of their time, and to our sponsor, Honeywell, and to my colleagues who work behind the scenes on the webinar, particularly Laura Gardner. A recording of this webinar will be available shortly on FlightGlobal.com if you want to rewatch or tell a friend about it. In the meantime, thank you all for joining us today, and I hope to see you at our next sustainability webinar in September, and details of that will soon be available too on our website. So I don't know about you, but I can't wait to fly in some of these aircraft, and it really feels like a very exciting time to be in aviation. Thanks very much, and goodbye.
Okay, thank you, Murdo.
Thank you.
Thank you.